Hello students, how are you? I hope you will be fine. So dear students, in today's session we will see isomerism. This is related to unit number 12 organic chemistry, some basic principles and techniques. So dear students, in today's session we will see isomers and isomerism. The types of isomerism. These are structural isomerism and stereoisomerism. So first, under structural isomerism, we will see chain isomerism, positional isomerism, functional group isomerism, metamerism, tautomerism, and under stereoisomerism, we will see geometrical isomerism and optical isomerism. So let's start our discussion. First is isomers. What are isomers? The organic compounds which have same molecular formula but different structures and chemical properties are known as isomers. For example, you see for the compound C4H10. For this compound, total number of carbon atoms are 4 and total number of hydrogens are 10. So this molecular formula, it can the structure of this compound having this formula can be drawn as 1, 2, 3, 4. 4 carbon in a straight line. All the carbon atoms bonded with single bonds, and after that total number of hydrogens. So with each carbon we will add number of hydrogens to balance its valency. See here total number of hydrogens are 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total number of hydrogen atoms, these are 10. Okay. So this is the straight structure. You can see this is a straight structure. Carbons are arranged in a straight line. For the same molecular formula, the name of this compound, it will be butane. The name of the compound, it will be butane. Okay. For the same molecular formula, we can draw different structures also. See how 1 carbon, 2 carbon, 3 carbon and 1 carbon as a branch. So with this carbon 3 hydrogens will be there, 3 hydrogens, 3 hydrogens and 1 hydrogen. So now total count 3, 6, 9, 1, 10. Total hydrogens are 10. Total carbons, these are 4. So this C4H10, this molecular formula, this is the molecular formula of two compounds. One compound is butane and second compound. So the name of this compound, it will be 2-methyl propane. Okay, the name will be 2-methyl propane. So we have two different compounds. So these two compounds which have same molecular formula are known as isomers. So now got it? What are isomers? Isomers means the compounds which have same molecular formula but different structures and chemical properties are known as isomers. So now we will see these are the isomers and the phenomenon, it is called isomerism. So what is isomerism? When two compounds they have same molecular formula, these are isomers, and this phenomenon is known as isomerism. So now we will see types of isomerism. First is, so types of isomerism, it is two types structural isomerism and stereoisomerism. What are structural isomerism? So simple, those isomers which have different structures only. Structures means the position of the atoms, molecules or group of atoms, and the position of multiple bonds, the position of functional group. So their position will be changed, their arrangement will be changed. So that is called structural isomerism. And stereoisomerism, so when the compound is arranged in three dimension in a space. For example, you have seen the tetrahedral structure, that tetrahedral structure of methane means this is a stereo structure. Why? Because the four hydrogen atoms, their orientation in space, it is tetrahedral. Okay, so stereoisomerism means when the compounds, these are arranged or these are placed in a space, so that structure is known as stereo structure. And the isomers, which have different position of the atoms or the molecules in space, not in 2D, I'm talking about 3D structure. So that is known as stereoisomerism. Under stereoisomerism we will see geometrical isomerism and optical isomerism. So first is structural isomerism, that is chain isomerism. In chain isomerism, see definition: when two or more compounds have similar molecular formula but different carbon skeleton, these are referred to as chain isomers, and the phenomenon is termed as the chain isomerism. It means in chain isomerism, the skeleton of carbon means where carbon atoms, their arrangement, it is different. Arrangement means, for example, if we have 5 carbons, then we can arrange 5 carbons in 3 different ways. First, 5 carbons in a straight line. Okay, this is straight structure. These are 5 carbons. 4 carbons in a straight line and 1 branch. And 3 carbons in a straight line and 2 branch. One is carbon above, one below. So here we have 3 different possibilities, 3 different structures or 3 different skeleton of carbon atoms. Okay, so this type of compounds, these are known as chain isomers, and the definition, the phenomenon is called chain isomerism. See how. First, 5 carbon is straight line, the name is normal pentane. 4 carbons in a straight line, 1 branch, the name will be 2-methyl butane. Okay, and it is also known as isobutane. 3 carbons in a straight line, 1 carbon above, 1 CH3, and below 1 CH3 more. So again you can see 5 carbons are there, and total number of hydrogen atoms, these are 12. So all these 3 compounds, first, second and third, all these 3 compounds have same molecular formula C5H12. So again, by the definition, when the molecular formula is same but the compounds are, their structure is different, chemical properties is different, then these are known as isomers, and the isomerism phenomenon is isomerism. So see here, the difference in these isomers, this is the difference in chain, that's why this is known as chain isomerism. Okay, so the name is 2,2-dimethyl propane. After chain isomerism, which is also known as neopentane. Okay, so in exam there is a question, structure of isobutane and structure of neobutane, it is asked. So now see, after chain isomerism, second type of isomerism, it is position isomerism. So in position isomerism, by the definition, in position isomerism we can understand it in a very simple way. Since the name is position, it means the position of side chain or branches, the position of multiple bonds, and the position of functional group. This is different. For example, in first compound, function group, it is in second position. So in next isomer, the position will be third, fourth, and so on. So the position of branches, function group, or multiple bond is different. These are known as positional isomers, and the phenomenon is position isomerism. See, in this case, we have two carbon skeleton is fixed. You see, we have 5 carbons in a straight line. But in first compound, the position of CH3 side chain, it is with second carbon, and in third case, second example, it is in third case. See here, this is the second carbon and this is the third carbon. So number position is different, 1, 2, 3, 4, 5. The position of this methyl, it is 2-methyl. The name will be 2-methyl and 5 carbons and pentane. Here the name will be 3-methyl because the position is different. So if the difference is in position, this is known as position isomers, and the phenomenon is position isomerism. See, name is 2-methyl pentane and 3-methyl pentane. In next case, now the position of double bond. So in position of double bond, we have 5 carbons again, 5 carbon is straight, so there is no difference in chain. All the 5 carbons are arranged in a straight manner. But the position of double bond, the name of this compound, it is pent1-ene, and in second pent2-ene. So the difference is in position of multiple bond. And in third case, you see here with second carbon there is OH, that is a functional group, and in second case third. So the name will be now pentane 2-ol, pentane 3-ol. So again, in all these 3 cases, you can see the difference is in position, not in the skeleton of carbon. So this is position isomerism, and the phenomenon is position these are position isomers, and the phenomenon is position isomerism. After position isomerism, now we will see the functional group isomerism. So in functional group isomerism, the functional groups are different. Okay, what will be the difference? The difference, it will be in functional group. For example, 2 or more compounds having the same molecular formula but different functional group are called functional isomers, and the phenomenon is termed as functional isomerism. See how. In this case, the functional group, this one is ketone. Functional group is ketone. Okay, because 3 carbons, CO functional group it is present. So this is ketone. What will be the molecular formula? The formula will be C3, 3 carbons, so C3H6O. This is the molecular formula. The name is propanone, which is a ketone. Functional group is ketone. In second case, you can see CH3CH2CHO. The name will be propanol. It's a aldehyde. Okay, so now see here ketone, it's a functional group. Here total number of carbons C3H6O. Here C3H6O. So the molecular formula, it is same, but carbon skeleton, so all 3 carbons are in a straight manner. There is no change in position of the functional group because there is no 2-on, 3-on and so on. So the difference is in functional group. One is ketone and second is aldehyde. So this type of isomerism, it is functional group isomerism. Okay. After functional group isomerism, next is metamerism. So in metamerism, what will be the difference? The difference will be only of the alkyl groups on both sides. Okay, it arises due to different alkyl chains on either side of the functional group. Either side means left side the alkyl chain will be different, right side alkyl chain it will be different. For example, you can see this is the molecular formula. For this molecular formula, I am showing here functional group as O. This is a ether. This is an ether. So in this compound, now we have to put here number of carbon atoms. So we have two cases. We can divide 4 carbons into two categories. First, in one side there will be 1 carbon, and in this side 3 carbons. And second possibility, 2 carbons on both sides. Okay, so this type of isomerism, it is metamerism. Means what will we do? On the both side of that functional group, the alkyl group, it will be different. See the structure of, for this compound. Here methoxypropane, this is the structure. You can see here CH3O C3H7. This is methoxy. Okay, methoxypropane. And second case, so now in these two cases you can see, in first case left side 1 carbon is there and right side 3 carbons are there. In second case 2 carbons are on both sides. So this type of isomerism, it is metamerism. Okay, so now the definition is clear. It arises due to difference in alkyl chains on each side of the functional group. So this is the metamerism. Okay, you can see this metamerism. Now next is tautomerism. Tautomerism, it arises when hydrogen atoms is in dynamic equilibrium. Dynamic equilibrium means the position of hydrogen atom, it is changing, means due to migration of hydrogen atom. See example, in all isomerism. In first case you can see the double compound we have here. This is the compound CH3COCH3. In first case, where are hydrogen atoms? So hydrogen atoms, their positions, 3 hydrogen atoms with this carbon, 3 hydrogen atoms with this carbon. So this is a ketone, but 1 hydrogen from this carbon, it is shifting to oxygen and the bond is shifting to this position. Okay, see how? Very simple way. I am drawing this structure, CH3 C double bond O C, 1 2 3, 3 hydrogens are there. From these 3 hydrogens, one will be eliminated. Okay, so what will we do here? Break this bond. So this bond is break. Okay, hydrogen is free. Once again break this bond. So once again here now the total number of bonds of carbon 1 1 2 3, one more bond here, 1 2 3 4. Now it is satisfied and hydrogen is free, so it will shift on this oxygen. So the compound will be, this will be the compound. So now why it is in all isomerism? Here it's not in all, it's a keto in all. Okay, see this is a in, double bond means in, this is all, and this is keto. So what will be the name of this isomerism? Overall we can write it keto in all isomerism. What is isomerism? Keto in all isomerism. So this type of isomerism is known as tautomerism. This is the tautomerism. Okay, so this isomerism, it is arising due to the shifting of hydrogen atom. Once again this hydrogen atom shifts on this carbon, so again this compound will be formed. So this is the tautomerism. After the tautomerism, now we will see stereoisomerism. Okay, so in stereoisomerism, as we have discussed that stereoisomerism, it means when the spatial arrangement means arrangement in space, not spatial, it's a spatial. Okay, SPATIAL, spatial arrangement or arrangement in space, it is different. So that type of isomerism is spatial isomerism. Under spatial isomerism, these are two types of isomerism, geometrical and optical. In geometrical isomerism, see what will happen. It arises due to the difference in spatial arrangement of atoms or groups. For example, see what we are doing here. We are writing the structure of the compound. Carbon, double bond carbon, okay. In space, hydrogen is left side, bromine is left side. With the second carbon, hydrogen left side, bromine right side. So this is the arrangement in space. This is the arrangement in space, okay. And this is the trigonal structure. Trigonal, why? Because this is forming trigone. These are forming trigone. So this trigonal structure, now you can see the structure, the position of hydrogen and bromine. You can see. Now see how we can exchange their positions. Carbon, double bond carbon, same. Hydrogen left side, bromine right side. But with second carbon, bromine is in left side and hydrogen is in right side. So now see what is the difference in these two compounds. Bromine, one bromine is atom with first carbon, second bromine with second carbon. So there is no difference in the position. The difference, it is in arrangement, spatial arrangement. Position means what? It's the right side or left side. So that is spatial arrangement. Geometrical isomers. So when this type of cases we have, this type of cases means when the functional group, which functional group? These bromine, these are on the same side of multiple bond. These bromine are on same side of multiple bond. This is known as cis. And if the bromine atoms, these are on the opposite side, you can see here these are opposite side, not same side. One is right side, this one is left side. Here right side, right side. So this case, this type of case, when where the atoms or the group of atoms, these are present on the different side, this is known as trans. So what are cis? What are cis? Cis means same side, trans means opposite side, in a diagonal. Trans means in a diagonal, okay. You can see here why in a diagonal. If it is a rectangle, then this is the diagonal, okay. And if this is the rectangle, same side. So this is the difference, cis and trans, okay. After geometrical isomerism, and the name will be same. See, name will be same. Cis 1,2-dibromo ethene. Second name is trans 1,2-dibromo ethene. Okay, I am not mentioning here position. Cis dibromo ethene. So the name will be IUPAC name. It will be actually cis 1,2-dibromo ethene. Okay. After the geometrical isomerism, now we will see the optical isomerism. Optical isomerism means, first let me tell you what is polarized light. Okay, plain polarized light. You see the normal sunlight, it has vibration in all directions. Vibrations in all directions. Okay, this is normal light. This one is normal light. And what is plain? What is plain polarized? Plain polarized light. So plain polarized light, it means when this sunlight, it is passed through Nicol prism, then the vibrations of all the radiations, it is in the same direction. This is the plain polarized light. Okay, this is plain polarized light. The position is vertical, 90 degree. When this plain polarized light, it is passed through a particular substance or organic compound. So see here we are showing organic compound. So in this plain organic compounds, when this plain polarized light, it is passed through this sample, the orientation or the direction of this plane polarized light, it is changed. Changed means if the vibrations it is in clockwise, it is changing clockwise. See here, angle is 90 degree, and now the angle is, it is shifting in clock direction. So this is known as dextro-rotatory. What? This one is dextro-rotatory. It means, see, in a very simple way, प्लेन पोलराइज्ड लाइट क्या होगा, जिसमें की वाइब्रेशंस कहाँ होगा, वर्टिकल होगा, पूरा 90 डिग्री में होगा. ये जो हमारे पास प्लेन है, इस प्लेन के क्या होगा, ये पूरा वर्टिकल होगा. इसको आप किसी भी एक सैंपल से डालेंगे, ऑर्गेनिक कंपाउंड से पास करेंगे, तो इनमें जो वाइब्रेशंस है, ये वाइब्रेशन क्या होगा, इस एक्सिस में चेंज हो जाएगा. चेंज होने का मतलब, अब ये हमारा वाइब्रेशन देख रहे हैं, ये तो हमारा क्या है, वर्टिकल. या तो ये किस साइड रोटेट कर सकता है, इस साइड रोटेट कर सकता है, या फिर इस साइड रोटेट कर सकता है. ठीक है, तो ये एक्चुअली ऐसा होता है, ऐसा नहीं कि ये थ्योरेटिकली है, ये प्रैक्टिकली चीज है ये, कि जब इस प्लेन पोलराइज्ड लाइट को आप किसी सैंपल से पास करेंगे और इसकी डायरेक्शन क्या होगी, क्लॉकवाइज यदि ये रोटेट हो रहा है, तो इसको हम कहते हैं डेक्स्ट्रो रोटेटरी, और सिंबल होता है इसका डी. डी मतलब डेक्स्ट्रो रोटेटरी, डेक्स्ट्रो रोटेटरी मतलब क्लॉकवाइज. और यदि इसका रोटेशन कैसा हो रहा है, एंटी क्लॉकवाइज, तो इसको हम कहते हैं लीवो, लीवो रोटेटरी. लीवो रोटेटरी मीन्स दिस वन इज लीवो रोटेटरी. तो इसका सिंबल क्या मिलेगा हमको, एल. तो हम ये देखें अब ऑप्टिकल आइसोमेरिज्म में डी और एल दो हमको आइसोमर्स मिलेंगे. एक जो प्लेन पोलराइज्ड लाइट को राइट साइड रोटेट करेगा, तो हमारे पास डेक्स्ट्रो आइसोमर्स क्या होगा, विच कैन रोटेट प्लेन पोलराइज्ड लाइट. इसको क्या करेगा, इसको करेगा ये क्लॉकवाइज. क्या रोटेट कर देगा ये, क्लॉकवाइज. कौन, डी. और एल क्या करेगा, ये एंटी क्लॉकवाइज इसको रोटेट कर देगा, ये होगा एंटी क्लॉकवाइज. तो ये हमारे पास फिनोमेनन मिलेगा ऑप्टिकल आइसोमेरिज्म. ये हम 12 में और डिटेल में पढ़ेंगे. सो ये यहां पर हो गया. सो दीज आर द टाइप्स ऑफ आइसोमर्स, स्ट्रक्चरल आइसोमर्स एंड ऑप्टिकल आइसोमर्स. आफ्टर दिस optical isomerism, so that's all for today's session. Now if you have doubt, you can contact me. Thank you.